Captain Stinky Socks. So obviously this has happened to all of us. We're stranded on an island and we have no boats, so we have to swim to the nearest laundromat. Obviously. What's the first thing we should do besides give up, considering this is the first example of the day? Crying is always an option. We should draw a picture. So here's the island. The shore. And here's the laundromat. That's a sock. All we know that this is 2, because that island is 2 miles due south of a beach, and 5 miles east of this point is a laundromat, so that means this is 5. He has 3 options. He can swim right to the laundromat. He could swim right to that nearest point on the beach and then run the rest of the way. Or he can swim to a point halfway between, not necessarily halfway, and then run the rest of the way. So we have to figure out which one of those 3 options would minimize his time. So in other words, we need to know where on the beach he needs to swim to. Either the laundromat directly, to the nearest point on the beach, or somewhere between them. Do we know where he should swim to? Say no. No. So why don't we call x the distance between the nearest point on the beach and where he swims to. So the path he's going to take, I'm going to draw in red here, would be from the island, he's going to swim to that point, and then run the rest of the way. So we have 2 parts here. We have a swimming portion and we have a running portion. Of the 2, the swim is the harder one, so let's get rid of that one first. Well, notice we're talking about distances, we're talking about rates, meaning how fast he's running, and we're trying to minimize time. If only there was a formula that related distance, rate, and time. So unless everyone teleported here today, you should all know the relationship between distance, rate, and time. Distance equals rate times time. So solve for t, because that's what we're trying to minimize. We're trying to minimize time. So if d equals r times t, what does t equal? So for our swim and for our run, we're going to have a distance and we're going to have a rate. And that ratio will give us time. So for swimming, notice, again, this is the portion that he swam. That would be the distance for swimming. Considering this is a straight shoreline, which I didn't write in the problem, but it's just assumed. What figure do we have here? A right triangle. So notice we're given 2 sides of a right triangle, namely 2, the x, and we need to find the hypotenuse. If only there was a formula that related the sides of a right triangle. Some dead Greek guy who started a cult and did not let his members eat beans. That's all true. Rhymes with Pythagoras. Pythagoras! What's the Pythagorean theorem? Very good. A squared plus b squared equals c squared. A and b are the legs. C is the hypotenuse. It doesn't matter which leg is which leg, so we could have 2 squared plus x squared equals c squared. What is 2 squared? What is x squared? X squared, and that equals c squared. So if you were to solve for c, what would you get? No, close. Well, you have to get rid of a square. How do you get rid of a square? Take a square root. When you take a square root of an equation, you technically include a plus or minus. Why for this problem do we not include a plus or minus? Meaning, why do we take the plus? You can't have a negative distance. Yes. So c is the square root of 4 plus x squared. So he's going to swim a distance of the square root of 4 plus x squared. By the way, if you did not figure this out, Captain Stinky Socks has a math minor. That's why he's able to do all this in his head. But he's not smart enough to not go out with his friends and be stranded on an island. But that's okay. So the distance for swimming would be 4 plus x squared divided by, what's the rate at which he can swim? 4 miles per hour, so just 4. So that's your d over r. So that fraction gives us the time it takes him to swim. Plus, this one goes a lot faster. How about running? How far is he running? We don't need to go that far. Remember, we want to keep it all in terms of x. We don't want another.
Minus x squared. The distance is x. That's how.
Right, so just 5 minus x. Does that make sense to everyone? Okay. So 5 minus x over, what's the rate at which he can run? Run.
Well, it says he can swim at 6 miles.
Oh, it says he can swim twice, apparently. That should say run here, people. Oops. This is why you don't... Oh, it won't let me do it. Will it let me do... Yep, sorry. He should run at 6. Unless he knows how to air swim, which would be awesome. Well, congratulations. This is your function. So this is your time function. What's the domain of this function? How small to how big can x be? 0 to 5. Is this a closed or open? Closed, because we can include those values. So now we're trying to minimize on a closed interval. So remember the steps. We figure out the critical numbers of the function between 0 and 5. We also figure out the functional values of the endpoints and of the critical values. And whatever one's the smallest, that's the one we take. So good news, everyone. We get to take the derivative of t of x. Okay, here we go. We can make it a lot prettier. I'm going to make it a lot prettier right here. Dividing by 4 is the same thing as multiplying by 1/4. And dividing by 6 is the same thing. Well, actually, you can break this up into 2 fractions, namely 5/6 and minus 1/6 x.